Section 1.5, Intersections, Unions, and Compound Inequalities. So we want to graph and write an interval notation. Now be careful when you read this. 0 is less than x, and x is less than 2. We want to make both of these things true at the same time because it says and. That's an intersection. We want both to be true at the same time. 0 is less than x is a little confusing for me. I prefer to read it as x is greater than 0. X is larger. The alligator always eats the larger one. X is greater than 0. Can't be equal to 0. Greater than 0. So on our number line, we're talking about going to the right. And at the same time, x is less than 2. Can't be equal to 2, we use a hollow circle. So where are both of these things true at the same time? Between 0 and 2. And we do not include the 0, we do not include the 2. So that's our intersection of 0 is less than x and x is less than 2. Here we have or. What does or mean? Or is the union, one or the other or both is true. X is less than negative 2 is down this way, to the left. Or x is greater than 4 to the right. So where is the union? It's where one or the other or both is true. The union is represented by the numbers to the left of negative 2 and to the right of 4. Write an interval notation. We forgot to do that. Let's do that real quick. So we have from 0 to 2, not including the endpoints. What about here? We have from negative infinity to negative 2. Remember, with positive and negative infinity, you always use open parenthesis. Or we have from 4 all the way to positive infinity. So that's our interval notation. We have to use an or to show that it is a union. In the previous example, x is less than negative 2 or x is greater than 4. Be very careful with that. Do not be tempted to write that as 4 is less than x is less than negative 2. Notice that when we have compound inequalities such as this, the smaller number must always be on the left. The smaller number needs to be on the left. The larger number needs to be on the right. That's not the case here. You have 4 is the larger of the two numbers, and it's on the left. You can't write the inequality this way. You must always have less than 2. So the less than part is fine, but the smaller number is not on the left. So this is not a valid compound inequality. You cannot use a compound inequality with 3 parts to show that x is on the right-hand side and the left-hand side. That's only for when x is between a range of numbers. So note that in general, for a is less than b, a must be less than x, and x must be less than b. And that can be abbreviated when you're talking about being between two values and it is an and situation, an intersection. So if a is greater than x and x is less than b, you can't abbreviate that as a is greater than x is less than b. You cannot have the inequalities pointing in opposite directions. It just doesn't make sense. So we have to have the smaller number on the left, and both inequalities must be less than or equal to. Let's solve this compound inequality. It's an and situation, so it's an intersection, and we want to isolate the x in both cases. On the left, we'll subtract 1 from both sides. That gives us a negative 6 is less than 3x. We need to isolate the x. We'll divide both sides by 3. Negative 2 is less than x. And let's solve this inequality. Subtract 1 from both sides. It gives you 3x is less than or equal to 3. Divide by 3, so we get the x by itself. And we have x is less than or equal to 1. So that's our solution for that inequality. We now want to graph it. Whoops, let's graph it. We'll draw a number line. We want both of these to be true at the same time. We have a negative 3, negative 2, negative 1, 0, 1. We want x is less than a negative 2. That's down here. X is less than or equal to a 1. Now we're talking about and, so we want both of these to be true at the same time. The intersection, where are they both true at the same time? That only happens when x is less than negative 2. So the intersection will be down here from negative infinity to negative 2. So we've solved it, we've graphed it, and we've written it as interval notation. So we've solved that problem. Let's look at this compound inequality. Notice again, the smaller number is on the left, that negative 5 is smaller. The larger number is on the right, that 4. And both inequalities are less than or equal to. So we're going to solve this inequality. We need to isolate the x in the middle by itself. So we're going to subtract 1. We have 3 locations now to subtract 1. Negative 6, 3x, 3. Divide all 3 locations by 3. Negative 2, x, 1. And that should be less than or equal to here. So on the number line, x is between these two values, negative 2 and 1. It cannot be equal to negative 2. It can be equal to 1. Make sure you do your hollow and your solid circle correctly. In interval notation, we use parenthesis to show it cannot be equal to negative 2. It can be equal to 1. That's a square bracket. One more example. This is an OR situation. An OR is a union. So we need to solve these problems separately. We need to isolate that x term. That gives us a 5x on the left is less than a negative 20. Divide by 5. That gives us x is less than negative 4. Or, on the right-hand side, we're going to subtract 8 from both sides. That gives us a minus 2x and a minus 8. Divide both sides by a minus 2. Oh, when you divide by a negative, you reverse the direction of the inequality. We have to remember that. So now this is an OR situation. We're going to draw our number line. So we have negative 4 on the left. There's a 0 in the middle. Positive 4. I'm only putting on the number line what I really need. X is less than negative 4. That's down here. This is an OR situation. So one or the other or both is true. X is greater than 4. That happens over here on the right. So we have the two ends represent our solution. Interval notation, forgot that. We have negative infinity to negative 4 or 4 to positive infinity. And that's our solution.